Okay, so we're going to look at different types of data today. Most of them you should have met in year 7, so it is revision, but I'm going to start right from the basics so that we all know what we're doing. And also we're going to look at different types of sampling techniques. And there's a vocabulary associated with all of those also. So if we look at when we collect data, data means information. And there are various kind of stages of what we do with that information. So first of all, we have to collect it. Then we organise it. Then we display it. And then we analyse it. So the collection part of the data has to start with the question or what the sample is about or the survey is about. And we'll talk about those words in a moment. Now, different types of data are used to collect, organise and display and analyse different types of information. There are 2 main types of data. Can anyone remember what they are? Tyler?
Primary data.
Not really. That might be science, is it? I don't know. Mathematically, it's slightly different.
Quantitative and qualitative.
Yes, but can you remember what we call them? That's the second word for them, isn't it? Yes, those two. I'll add those in. But the simpler versions of qualitative and quantitative are
Numbers and words.
numerical and categorical. Numerical and categorical. And of course, the things that you've just said, one of them is qualitative, one of them is quantitative. Which is which?
Quantitative using numbers and
Yeah.
qualitative.
Yeah, so this one, another word we could call it is quantitative. And this one is qualitative. So it's very important because the different types of data are displayed differently. So if, for instance, you're doing a bar chart or something, you have to know whether the data is numerical or categorical, for instance. Now, numerical data is also split into 2 types. Does anyone know what those 2 types are? Okay, they're split into continuous and discrete. Categorical data, what kind of things would that be? What type of things would class as categorical data?
They have things.
Yeah, so
Colour of things.
yeah, good. Colour, flavour, type, yeah, what it looks like. So things that are categorical data would be, for instance, if I was going to do a survey and ask you your favourite flavour of ice cream. That would be categorical. Your favourite soccer team, your favourite football team, your favourite flavour of pizza. You know, which suburb you live in, that kind of thing. So they're all categories. And so they are what, do you think, continuous or discrete? Discrete, yeah, they are discrete, that's right. Because you can't, if you say, well, you could if you were being difficult, but if you know, I said to you, what's your favourite flavour of pizza? And you said, well, it's a margarita with a bit of Hawaiian with a bit of meat lovers. You can't really say that, you have to choose one of them. Now, numerical data, being continuous and discrete, this often causes problems for people to decide which one that their particular type of data fits into. And there's an easy way to remember. So discrete data, numerical data, is where the number is an integer. Okay, it's a whole number and it can only be one value. Okay, so it's one value. So for instance, if I was asking you what your house number was, unless, you know, you live in Harry Potter world and you live at 9 3/4 or whatever, you tend to live at an integer, don't you? I live at number 3. You know, Matt lives at number 8 over the road. What number do you live at, Holly?
20.
20. So they're all whole numbers, okay? You don't live kind of in between 20 and 21, do you? It might have a letter with it, but, you know. Discrete things also would be your shoe size. So you are either a 6.5, a 7, a 7.5, an 8, an 8.5 or a 9. And again, you could be difficult and say, well, one foot's bigger than the other, and my foot is actually 7 3/4 on one foot, but they don't make shoes in that size, so you're just going to have to pick an 8.5 or a 9, aren't you? So discrete numerical can only be one value. Continuous numerical data can be any value within that range. So for instance, if we were going to do the heights of everyone in this class, we'd have a minimum height, say 140, I don't know, I'm just guessing. And we'd have a maximum height, someone like Sheldon who's really tall, he might be 180, are you? 180 centimetres? Whatever. So let's say or Lachlan, he's tall. How tall are you, Lachlan? Oh, okay. So let's say we go from 140 to 180. Well, you could be any value in between there, couldn't you? You could be 140.5 or 163.5 centimetres or 128 point. Do you see what I mean? So that's why it's continuous. So continuous data can be any value in between, and it doesn't have to be an integer. So let's have a think about what some types of data might be. So the numbers of children in the families in this class, what would that be? What type of data would it be? The numbers of children in your classes, in your families. Noreen?
Discrete.
Categorical, numerical?
Numerical.
Numerical. Numerical discrete, that's right. Because, you know, you can't have 1.5 children in a family, can you? You know, it just doesn't happen. And I know we could go down, you know, step parents, half brothers, half sisters, but let's just keep it simple, okay? So number of children, bless you, in a family is numerical discrete, okay? The heights of students in this class. Well, I've already said that. What's that? Jodelle?
Numerical continuous.
Numerical continuous. Okay. The favourite TV programme of students in this class? Categorical. The shoe size of each student in this class? Numerical discrete, that's right, okay. So, when the number of children must be a whole number, so it's discrete, numerical. Exact height can be any number, so it's numerical continuous. Favourite TV programme is a category, and then the shoe size is also numerical discrete. So if we talk about those types of data, you just have to think through what the answers might be to your question. And if the answers might really vary, then it's probably going to be numerical continuous. If the answer is going to be one thing, it's going to be categorical. Okay, has everyone written this down? Can I rub it off now? So let's have a little think about how we collect data. So sampling techniques, okay. So when we collect information, you think of a question that you need to ask, and then you ask the question. Now, if you ask every single person to whom that question would apply, does anyone know what that group of people is called? It's a word that you might get mixed up with humanities. It's population. Population. Now, for instance, let's think about the question, do you agree with school uniform or not? Now, if we were going to ask a population about that, who would we need to ask? It's applying just to NBC, but should NBC give up their uniform or not? Who would you need to ask?
Students.
All the students.
Teachers.
All the teachers. Everyone in the school community, which involves who else?
Parents.
The parents, the P&F, the school board, exactly. So can you see why it's important that when you are asking a question that you need to make sure that everybody is represented in that answer? So the population is all people to whom the question applies. The question applies. So what do you think a sample is?
Like a small quantity of people.
Very good, yeah. A selection of those people. So a selection of people to whom the question applies. Now, when we ask everybody, it's got a special name, and when we ask a sample, it's got a special name. Does anybody know what it's called when everybody to whom the question applies has to respond? Eva?
Is it census?
A census, well done. It's a census. And we have those in Australia, and they are, it's a legal requirement to take part in it. You know, they ask you how many people are living in your house and what your family earn and what people do and etc, etc. So a population, if you ask everybody the question, it's called a census. If you only ask a sample of the population, what's it called then?
Is it survey?
A survey, well done. A survey. Now let's think about surveys, shall we? I want to find out what shop people do their weekly grocery shopping in. So I go to Lakelands Shopping Centre and stand outside Coles. And I ask everybody who is walking by which shop they do their grocery shopping in. That's not fair, is it? Why not? Because I'm standing outside of Coles, absolutely. So, what's that called? Begins with a B.
Biased.
Biased, that's right, okay. So you can have biased and unbiased surveys. So for instance, if I really wanted to find out what shop people did their grocery shopping in, and I didn't have like a captive audience like you lot, and I could just ask you where your parents went, where, for instance, should I go to stand to ask people, do you think?
Or outside the shopping mall.
Outside of the shopping mall. But the shopping mall would have to have what in it, remember?
Both the shop.
Or all three, yeah, now there's Aldi, isn't there, as well? Because a lot of people go to Aldi now. So when it was just Coles and Woolies, it was a bit simpler. So you could go to the Forum, there's a Coles at one end and a Woolies at the other. So where would you have to stand?
In the middle.
In the middle, absolutely. Because if you go one end, you know, the Target Coles end, it's more likely that the person shops at Coles. So it skews the answers. It's biased. If you were nowhere near supermarkets, that might be even fairer. You know, if you went to the foreshore, for instance, and stood on the foreshore and asked people. There is a little Woolworths there, but it's unlikely that people tend to... Your brother works there, doesn't he? Yeah, I thought so. There is a little Woolies there, but it's unlikely that people would do their big grocery shop there, because it's only a small one, isn't it? But however, you are right. Okay, so biased and unbiased samples and surveys, you okay? Are to do with making sure that the question and that the responses you get are fair. So, for instance, if we wanted to know about should NBC give up its school uniform, and we only asked you guys, would that be a fair sample? No, it'd be very biased, wouldn't it? I wonder what the answer would be. Okay, so these things, are these samples or populations? So grade 8 students at Marysville High School were asked for their favourite cartoon show. Population or sample? Sample. The fastest runner is chosen to represent the school after everyone has taken part in the trial. It's population, yeah. A census, yeah. Every 1,000th person on the electoral roll is asked who they would vote for at the next election. Every 1,000th person. It's a sample. A TV show asks parents to phone in to vote yes or no on outlawing smacking children. Sample, that's right. Okay. Okay.